saw you guys doing these sample problems before. You were working on something like that. Now, I want you guys to be very clear. When I ask you to draw a skeletal structure, okay, and I ask you to draw a skeletal structure, if you go like this, shorthand, you're like, oh, there's 1, 2, 3 hydrogens, 2 there, 1 there, 2 like that. I know what you're doing. You're counting how many hydrogens there are. But if I ask you to draw a structure and you leave those green lines like that, those are not hydrogens because you did not draw them in. If you expect that to be a hydrogen, you have to draw the hydrogen. Because if you don't, what have you actually drawn in this molecule? That is a carbon. That right there is a carbon. So what does it actually look like? It looks like a CH3. CH3, CH3, and so forth all the way around. Okay, so when I ask you to draw a nice skeletal structure, you can't be just drawing these little tick marks so you can count your hydrogens. Because the tick marks will count as carbons. But if the problem is just saying, hey, count hydrogens, then you can use any rationale or any a way that you want to count hydrogens. It doesn't matter to me. But I just want you guys to be aware, when I ask for structures, those two right there, those are not hydrogens, those are methyls, we call them, or a CH3. All right. So if we come back to this first one, let's work on this one right here, class. Let's start with the question, what functional groups are present? You can just shout it out. There's an aldehyde. Okay, perfect. Where's that aldehyde?
On the far right carbon.
So there's an aldehyde right there.
And there's a methyl.
Okay. Methyl groups aren't necessarily a functional group, but you are describing a part of the molecule. That there's a methyl, so that works. Yeah. Say that again? Alkene. Alkene, yes, a double bond. So there's our alkene right there. Okay. Now, how many carbons, class? What would you say? Shout it out. What are you counting here? 7. Do I have 6? 8? 7? So I'm going to represent the carbons with the green dots here. 1, 2, 3, 4, 5, 6, 7. Perfect. Now let's use tick marks here to count hydrogens. How many hydrogens do you have? Okay, I heard 11. I heard 12. Do we want 13? No? What do we have? How many hydrogens on this first carbon? 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where's isn't it just 11? Yep, the aldehyde right there, that's not shown. Okay. How do I know there's a hydrogen on that carbon right there? Because that carbon right there, what was it shown before? What did it look like? It has 3 bonds. So we know it has to have 4 bonds if it's neutral. So we have that secret hydrogen that's not being shown. So what was that? Is that 11? That's 12. Okay? Perfect. Does that make sense? Okay, what functional groups do we have on this guy? A ketone and an alkyne. We have that triple bond there. So if we count carbons, how many do you count there? 5? 6? 5? We have a debate here. Let's count them. 1, 2, 3, 4, 5, 6. We have 6 carbons. So if we draw out the Lewis structure for that, we have our CH3, and then that's connected to a carbon double bonded O, to a CH2. So if I number these, carbons 1, 2, 3, 4, 5, and 6. 1, 2, 3. Carbon 3 is connected to a CH2. And that's carbon 4. Carbon 4 is connected to a carbon 5. And carbon 5 has to have a triple bond next to another carbon, carbon 6. What's missing on carbon 6 in my Lewis structure? Do you see it? What's missing? There's the hydrogen. Right? So when you draw your skeletal structure shown here, you can draw it like I did. That's fine. Or you could extend that bond out, but if you extend that bond out, you have to draw the hydrogen. So now you can count how many hydrogens there are. We have the Lewis structure there, so it's kind of cheating, but 1, 2, 3, 4, 5, 6, 7, 8. All right? You got to be able to make that connection between this structure and that structure, counting all the hydrogens. Okay, now we have this guy. What functional groups do we have in this one? There's 3 of them.
Two ketones, alkyne.
Alkyne, we have a ketone. So here's our alkyne. Here's our ketone. Okay, and this right here is called an amide. Now, if you are the type of person to make flashcards, you probably go to the textbook and say, hey, a ketone, the generic structure of a ketone looks like that. And that's what you're just going to memorize and memorize and memorize. But you have to be able to apply what that means. Because what do the R's mean? Just anything that's carbon. And don't you see that right here? Here's our carbonyl. There's our carbonyl, and then we have carbon directly attached to it. So you have to be, if you say, okay, those are ketones, you need to be able to expand it out and look at a real molecule with stuff all around it. So there's a cautionary tale right there about just using flashcards like that. You need to be able to interpret what they mean. Okay? So we have an amide, a ketone, and an alkyne. Now, in this new molecule, is this alkyne right? Whoa, not that. Is this alkyne right there? Is it an internal or a terminal alkyne? It's internal, because what we have here is a generic structure that we could say R. When you have your carbon triple bond, and if it's connected on both sides with carbon, that's internal. But if you have something like our previous example up here, carbon triple bond with an H and an R, do you see there? That is a terminal alkyne. So you need to be able to identify the distinctions between the two, internal and terminal alkynes. Dad joke coming. It's going to be all kinds of fun. Okay? So how many carbons, class? You guys count them up. Tell me, shout it out once you think you have an answer. How many carbons are in this molecule? 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. A lot of people, when they have questions like this on exams and I say count how many hydrogens, oftentimes people forget the hydrogens that are on the heteroatoms. Okay? When I say hydrogens, I'm not saying just the ones on carbon. I'm like, how many hydrogens are in the entire molecule? So watch out for that pitfall. Okay? So what if we do another problem? Now, introducing some more ring structures here. Oh, question, yes.
So for those structures, I don't think I'm the only one who made that mistake. Is there a way to tell when those triple bonds are separate carbons?
when they're separate? Is there a way?
Yeah, if you go back up to the drawing, I think I'm not the only one who mistaken those end caps for being a single triple bond rather than multiple.
But think about it. What is a bond doing? There's just 6 electrons just shooting out of an atom? No, a bond is between 2 entities. So you have to have 2 carbons in between a triple bond.
No, I mean in the sense of like it was hard to tell at the end there if that was a single triple bond rather than it being a triple bond and then another single bond after that.
Okay, so you're saying if I draw another one real quick,
Yeah,
a distinction.
We thought it was just one triple bond at the end rather than it being a single and then a triple.
This will just take practice for you guys to catch that, what it looks like. Yeah, you see, look at that. I'm trying to draw all those 3 bonds right there the same length. But then when you come here, look at that. I have something that's extending out from those 3 bonds. So that is a carbon. That's a methyl. Like that. Okay? Does that make sense?
Yeah.
If you extend it out, it's either going to be some type of carbon or you have to draw on the hydrogen. Question?
Why wouldn't you make it like a
Okay, hang on, I can't hear.
Why wouldn't we make it a separate diagonal then?
Why don't we?
Like, why don't we split it out?
So why? Let's extend that out. You're saying, why don't we go like this, triple bond, and go like a diagonal like that? Anyone have a reason why?
The way the triple bond, like the conformation, the shape of the molecule, it keeps
Yeah, it doesn't match the shape. It's completely 100% wrong. And it's a valid question, okay? I'm not picking on you at all. It's just, from my perspective, doing this for 100 years, like, yeah, that's horrible. It doesn't work. But for people that are learning, well, that's a reasonable question. What is the hybridization state of that carbon? That's sp. So if it's sp, what do those sp orbitals look like around that carbon? They're 180 degrees from one another. And so when you bring in another carbon, and that's sp hybridized, it's going to come in this way and this way. So the bond angle has to be linear, 180 degrees. Yeah, so if you do draw a structure like an alkyne with a bond angle that's not 180 degrees, that's points off. Because it's wrong. Okay? You can't approach me and be, well, that's just a silly mistake. I'm like, yeah, silly mistake that costs you a point. Like, there's not going to be any sympathy for giving you points back when you make silly mistakes. If it's a mistake, it's a mistake. Okay? It has to be drawn correctly. But no, good questions. Are we seeing, yeah, those triple bonds, it can be tricky on how to interpret what they mean. Okay? Good. Good. What if we have, I saw some people, I know they were just counting hydrogens. Okay? But they did tick marks like this to count the 2 hydrogens right there. Okay? What does it actually look like? When you draw a zigzag structure, we have a carbon right here. That's that bonded to another carbon, bonded to a second carbon. So we have 2 carbons. Those 3 carbons are in the same plane. So where's the hydrogens right here? Do we just draw them like this? The way that I drew it there suggests that the hydrogen and all the carbons are all in the same plane. But with the model that I showed you last time, is that the shape of a sp3 hybridized carbon? Because that carbon's sp3 hybridized, is it not? So what is the shape that it's supposed to have? It starts with a T. Tetrahedral. Okay? So if it's tetrahedral, what does it look like? Well, we would have to have a wedge and a dashed hydrogen. So when I'm asking you guys to represent molecules, you need to understand three-dimensionally what that means. And if you just draw lines, and those lines don't mean anything to you, then you need to take a step back and get to that point. We are drawing molecules to the best of our ability on a two-dimensional page, okay? But you will see in your textbook, you will see them draw it like this, and they're just doing that just for speed and just to get through it faster, easier to draw. But what does the molecule actually look like? We have wedges and dashes. We have wedges and dashes. Now, the main point that I wanted to get across is do not do this. Okay? Do not draw a wedge and then a dash like that. When you see the apex, okay, of that bond, everything goes on the point. So where would I put the hydrogens on this carbon? Would I draw a wedge here and a dash here? No, because that's not the apex. Okay, we would draw it, a wedge there and a dash there. All right, it's very important, guys. I'm being very particular, and you may think that I'm just being silly. But trust me, when you progress through the course and get into upper division courses, this is critical. So I'm just setting the groundwork for you, yeah.
So there'll be like questions or like pre-response questions I'll ask like to represent the hydrogen atoms in the planes.
Well, you just have to pay attention to what the question's asking. Okay? Yeah, I can ask all different ways to see what you understand about this. Okay? But I don't think I answered your question fully, though.
Just like will there be questions that will ask us like, oh, draw the hydrogens within the planes, like the wedge and the like how you represent them there. Are we gonna be asked like to draw them like that in some cases? And
Depends.
okay.
As long as you know what I'm talking about, it doesn't matter if I'm going to ask that type of question or not. Just know what I'm talking about. Okay? Question up that. That is a good question. So if you draw a zigzag, is there a difference between those two molecules? Clearly how it's drawn, yeah, there's a difference. The wedge is on one side and the wedge is on the other, right? But that's saying the same thing. Because what does that wedge mean to you? It's sticking straight out at you. Okay? This wedge is what? Sticking straight out at you. There's no difference if it's on the right or the left. Right? It means the same thing, just straight out. Same thing with the dashes. Good questions, yeah.
I had a question about the last functional groups that we were labeling. I think, or at least from what I saw, I thought amine was NH2, but the one that was labeled was just an NH. So I just wasn't sure if I was wrong with the definition or not.
Okay, so that you said, if I heard correctly, you said amine.
Or amide.
Okay, an amide. Yeah, you can have different types of amides.
Okay.
So you could have an amide that looks like this. Well, generically, you could just say like this.
Okay.
So you could have two carbons. You could have two hydrogens. You could have one carbon, one hydrogen. They're all a amide.
Okay, cool.
Good question. Yeah, right here.
So not two ketones, it's just one amide and one ketone?
Yeah. Because what's directly attached to that carbonyl carbon? That's the carbonyl carbon. For a ketone, what's directly attached to the carbonyl? Two carbons. With an amide, there's a nitrogen and a carbon. And then as we progress, you're going to see molecules that look like this. What is the functional group there? A lot of people will say ketone. But no, ketones are two carbons directly attached. This has an oxygen and a carbon. That's a different functional group, and that would be an ester. Okay? Any other questions? Okay, let's see here. Did I draw the 6-membered ring or 5-membered ring? No. Okay, let's go through this problem here. We'll do this one real quick. So what if I draw a 5-membered ring here? And I asked how many carbons are there? If we do that real quick, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have 9 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Okay, so what I want you guys to do here is I'm going to draw a molecule, a little bit more complex. I'm going to give you guys 10 minutes to answer the questions that we've been looking at. What functional groups, how many carbons, how many hydrogens? Okay? Okay, so there you go. How many carbons? How many hydrogens? What functional groups are present?